Okay, dear students, now welcome to the second part of the video lesson, some basic concepts of chemistry class 11 science. In my previous video, I had done four numericals from this chapter. Today, the fifth one is here on the board. The question says, how many electrons are present in 3.2 grams of methane? How many electrons are present in 3.2 grams of methane? You know, methane chemical formula is CH4. The molecular formula is CH4. So, if you draw the structural formula of methane, it becomes something like this: CH4. These four electrons are the electrons of carbon in the valence shell. Inside, in the inner shell, there are two more electrons. So, if you see 4 plus 2, 6 plus 1, 2, 3, 4. There are altogether 10 electrons in one molecule of methane. Hence, we can say one molecule of methane has 10 electrons. Now let us come back to the question, my dear students. Okay, now look at the question. How many electrons are there present in 3.2 grams of methane? So, the grams, the amount, the mass of methane is given. 3.2 grams of methane will have how many electrons? That is the question. So, to solve this problem, the first step is gram molecular mass of methane. The gram molecular mass of methane, the atomic mass of carbon is 12 and hydrogen is 1. So, 12, 13, 14, 15, 16. 12 plus 4 is 16. The gram molecular mass of methane is 16 gram. So, 16 gram is 1 mole. If 16 gram is 1 mole, so we can say this 3.2 gram is 0.2 moles. So we have converted this 3.2 grams of methane into mole. Now, number of molecules of methane in 0.2 moles of it will be equal to 0.2 multiplied by the Avogadro's number. 1 mole of any substance contains Avogadro number of molecules. But here, the number of moles of methane is 0.2 mole. That is why the number of molecules of methane in 0.2 mole will be 1.204 into 10 to the power 23 molecules. Therefore, in the final step, you can write down over here. Now, one molecule of methane, CH4, has, we already know, it has 10 electrons, 6 in the carbon and 4 from the 4 hydrogen. So, there are 10 electrons. Now, we can write down. Therefore, 1.204 into 10 to the power of 23 molecules of methane will have this number multiplied by 10, which will give me the total number of electrons which are present in 3.2 grams of methane. So, the answer is 1.204 into 10 to the power of 24 electrons. So, we can say that 3.2 grams of methane will have 1.204 into 10 to the power of 24 electrons. Now, my dear students, let us move to the next sum, that is question number 6. Let me write down the question on the board over here. Okay, now dear students, let us come to the next sum. Look at the board and try to copy the question. The question says, number 6, chlorophyll. Chlorophyll, the green coloring matter of plants, contains 2.71% of magnesium by mass. Calculate the number of magnesium atoms present in 3.50 gram of chlorophyll. The atomic mass of magnesium is given as 24.3. Now please copy this question. I am waiting for you to copy the question. Okay, now look at the solution part for this question. You must have finished copying the question. For this question, to find the number of atoms, we have to use, remember this formula. There is a formula over here. Number of atoms is obtained by dividing mass divided by molar mass into Avogadro's number, 6.023 into 10 to the power 23. Here, mass of magnesium in chlorophyll, it is given 2.71%. Okay, so that is why 2.71 divided by 100 into 3.5 gram. It is given in the question. Magnesium, the number of magnesium atoms in 3.50 gram of chlorophyll. So 2.71 divided by 100 into 3.5 will give us the mass of magnesium in chlorophyll. So, but the question is saying calculate the number of magnesium atoms in 3.50 gram of chlorophyll. So, to get the number of magnesium, so now you can see over here, After we get the mass of magnesium in chlorophyll, the percentage of magnesium, it was given 2.71%. So that is why we obtain the mass of magnesium in chlorophyll, the given mass of chlorophyll. So it is coming to 0.099485 gram. Therefore, number of atoms of magnesium, apply this formula, 0.09485 divided by 24.3 into Avogadro's number, which will give us a value of 2.35 into 10 to the power of 21 atoms of magnesium. So this is my answer. Therefore, we can say that the number of magnesium atoms in 3.50 gram of chlorophyll is 2.35 into 10 to the power of 21 atoms. Now, let us go to the next sum, my dear boys. That is question number 7 in this chapter. Okay, now let us come to the next question, that is number 7. Here, please copy the question. Commercially available concentrated hydrochloric acid contains 38% by mass. Subpart 1. What is the molarity of the solution? The density is 1.19 gram per centimeter cube. And subpart 2. What volume of conc HCl is required to make 1 liter of 0.10 m molal HCl solution? Now please copy this question. For solving subpart 1, please copy the formula also. Molarity is equal to percentage by mass. Percentage by mass into density into 10 divided by molecular mass. Because here the density is given in 1.19 gram per centimeter cube. That is why we are putting over here 10 divided by the molecular mass of hydrochloric acid. Copy the question. I am waiting for you all to copy the question. Okay, now look at the first part. The question says, what is the molarity of the solution? The density of the 38% by mass HCl, conc HCl is given 1.19 gram per centimeter cube. So, apply this formula. Please learn this formula as well. Molarity, whenever percentage by mass of any compound is given. Remember this formula to calculate the molarity. Percentage by mass into density multiplied by 10. Density is given in gram per centimeter cube divided by its molecular mass. Hydrochloric acid molecular mass is 1 plus 35.5, which gives us 36.5. So, if you put the values over here, percentage by mass of hydrochloric acid is 38 into 1.19 into 10 divided by 36.5. This will give us a value of 12.38 m. So, the molarity of 38% hydrochloric acid concentrated, the answer is coming to 12.38 m. That is the first part of the answer. Now, look at the second part of the question. What volume of conc HCl is required to make 1 liter of 0.10 m HCl solution? So, here we have already got the molarity of this concentration of hydrochloric acid. So, here we have to apply the molarity equation which is given on the board. M1V1 is equal to M2V2. Have a look at it very carefully and try to figure out in your mind what is going to be the next working. Now you can see over here the molarity equation. M1V1 is equal to M2V2. Now the question says, what volume of conc HCl is required to make 1 liter 0.10 mHCl? This 1 liter and 0.10 mHCl, make it as M2V2. The second strength, the second molarity value given is 0.10. 0.10 into V2. Volume 2 is 1 liter. So let it be 1 over there. And then on the left hand side, M1, V1. We already know M1. The value of M1, it is given, we have calculated as 12.38 m. So 12.38 into V1. This is what we are supposed to find. What volume? That is V1. So 12.38 into V1 is equal to 0.10 into 1. So upon simplification we get the value over here. V1 is equal to 0.10 into 1 divided by 12.38. We are going to get the answer in liters. We can convert after that the answer in what you call centimeter cube or milliliter as well. Now try to simplify this. I am waiting for the answer. It comes to roughly 8.1 centimeter cube. 8.1 centimeter cube, and that is the second answer. So here there are two parts to this question. The first part was to calculate the molarity of the solution given density, and second part, what volume of conc HCl is required to make 1 liter of the solution whose strength is 0.10 m HCl. So that 1 liter and 0.10 m HCl becomes M2V2. M2 and V2. So M1 V1 is equal to M2 V2. This M1 we have already calculated in the first part. The molarity over here 12.38 m. So 12.38 into V1 is equal to 0.10 into 1. Therefore V1 it is coming to 8.1. I have converted it already into centimeter cube because you will be using liter, no? So it is already converted, the answer is already converted into centimeter cube, 8.1 ml. So this is the second answer. Now my dear students, let us go to the next sum, that is number 8. Let me write down the question on the board after rubbing this. Okay, now dear students, look at the next sum on the board over here. This is a problem based on molality, and I am sure that you must have gone through the definition of molality from the notes which I have given you earlier. Please try to go back to the definition of molality which I have given you earlier in this chapter. Okay, I am waiting for the revision. Okay. Now, as per the definition which I have given you earlier for molality, if you see over there, number of moles of the solute, will you get the formula? Molality is number of moles of solute divided by what? Volume of mass of the solvent. Yes, mass of the solvent in kg. So molality is represented by the alphabet small m. Molality is number of moles of solute divided by mass of the solvent in kg. Molality is number of moles of the solvent divided by mass of the solvent in kg. Molality is number of moles of the solute divided by mass of the solvent in kg. This is the formula to remember to find out the molality. Now this question over here, the solubility of barium hydroxide crystals BaOH dot 8H2O in water at 288 Kelvin is 5.6 gram per 100 gram of water. That is the solubility. What is the molality of the hydroxide ions now? We are talking about the hydroxide ions. What is the molality of the hydroxide ions in the saturated solution of barium hydroxide at the same temperature 288 Kelvin? The molecular mass of barium hydroxide is given. It is 315 grams. It is 315 grams per mole. And I have just written down the atomic masses also for barium. It is 137, I guess. Oxygen is 16 and hydrogen is 1. Now over here to do this sum, it is given over here 5.6 gram per 100 gram of water. The solubility is given. So the solubility of barium hydroxide crystals in water at 288 Kelvin is 5.6 grams per 100 gram of water. And the molecular mass of barium hydroxide is given 315 grams per mole. So by using this, what we can calculate is over here the number of moles present in 5.6 grams of barium hydroxide. So let me first copy the question. I am waiting for you all to copy. Okay, now look at the board over here. Number of moles in 5.6 grams of barium hydroxide crystal is obtained by dividing 5.6 divided by 315. That is coming to 0.018 mole. Number of moles in 5.6 grams of barium hydroxide crystal is this 5.6 divided by 315, that is 0.081 mole, 0.018 mole. Now the question is talking about hydroxide ions. Molality of what? Hydroxide ions. So number of hydroxide ion moles present in 5.6 grams of barium hydroxide crystals will be 2 multiplied by this, because if you look at the formula of barium hydroxide over here, there are 2 hydroxide ions. That is why we have to multiply 2 into 0.018, which is coming to 0.036 moles. So 0.036 moles is the number of hydroxide ion moles present in 5.6 grams of barium hydroxide crystals. Now mass of the solvent, over here the solvent is water. It is given in grams, 100 grams. So we need to convert this 100 grams into kilogram. So that will be 0.1 kg. Why are we converting to kilograms? Because the definition, the formula of molality is number of moles of the solute divided by mass of the solvent in kg. That is why we need to convert this mass of the solvent from grams to kilograms. So finally, molality, applying the formula of molality is equal to the number of moles of the solute 0.036 divided by mass of the solvent in kg 0.1, that will come to 0.36 m, small m. This small m, it is the symbol to represent the concentration term which is called molality. Now we have come to this, the 8th sum is also over. Please go through the working. I am waiting for you all to go through the working nicely and copy it down and look at it carefully and go through the steps to understand it properly. I am now going to the next sum. Okay students, now let us come to the next question, that is question number 9. This is a problem. It is based on molarity. The question says, calculate the mass of sodium acetate CH3CONA required to make 500 ml of 0.365 m solution. The molar mass of sodium acetate is given as 82. Now, you must have gone through the formula which I have given you to calculate molarity. The formula is mass of sodium acetate into 1000 divided by the molecular mass into volume of solution. Now this is the formula to calculate the molarity of the given solution. So now please write down the formula. Molarity is equal to mass of sodium acetate into 1000 divided by molecular mass into volume of solution. Now look at the question. What is given over here? The molarity is given. The molarity is given how much? 0.365 m. Is it given? Okay. Then mass of sodium acetate, it is given anywhere? No, it is not given. So we are supposed to calculate the mass of sodium acetate. So we will make this mass of sodium acetate as the subject of the formula. So, or you can write down mass of sodium acetate is equal to molarity into molecular mass into volume of solution divided by 1000. So try to figure this out. Mass of sodium acetate is equal to 0.365 into 82. 0.365 into molecular mass of sodium acetate is 82. Multiplying this into 82 into multiplied by volume of solution. The volume of solution is given in milliliters, so we multiply it by 500 ml. This is multiplied to this and this, then it is divided by, then the entire thing will be divided by, what is left over there? It is divided by 1000. So I divide it by 1000. So upon simplification, now come on, use your scientific calculators to simplify this mass of sodium acetate. It will come roughly to say 14.965 gram. It will come to 14.965 gram. So this is the mass of sodium acetate which is required to make 500 ml of 0.365 m solution of the required concentration in terms of molarity. So that is the answer. Now my dear students, this is a very easy sum, direct application of formula to calculate the mass of sodium acetate from the given value of molarity. Now let us go to the next sum, that is number 10. I am going to write down the question on the board. Okay. Okay, dear students, now come to the next sum. Let me explain you the sum first. Okay. Now this is question number 10, part 2 of the video chapter, some basic concepts of chemistry, class 11 science. 4.15 gram of an acid. The name of the acid is not given over here. 4.15 gram of an acid are dissolved in water, and after putting in water, the volume of the solution is made up to 500 ml by adding water. It dissolved completely. Now 500 ml is the volume of the acid which is prepared. Okay. Now the second part over here, 20 ml of this acidic solution requires 20 ml of this solution requires 20 ml of n by 10 sodium hydroxide solution. Sodium hydroxide, it is a monoacidic base. Okay. 20 ml of this acidic solution requires 20 ml of N by 10 sodium hydroxide solution for neutralization, to neutralize the reaction. If the acid is dibasic, calculate the molar mass of the acid. So they are saying us, if the given acid, this unknown acid, if it is dibasic, means it is able to displace 2 hydroxyl ions or produce 2 hydrogen ions in solution. Dibasic is the word which is used, which you have already learned in class 10. So we are supposed to calculate the molar mass of the acid. Now let me solve the question over here. Now please copy the question while I wait for you all to copy the question. Okay, now look at the question. You must have finished copying the question. Now the solution part. Let equivalent mass of the acid, the unknown acid, be capital E. Now from the formula of normality of any substance, now normality, let it be N1 of the acidic solution. The normality of the base, let it be N2. Okay, it is N by 10 means 0.1 N. So normality N1 of the acid solution, the formula is W, the mass of the acid, divided by E, equivalent mass of the acid, into V, the volume in liters. So this is the formula. Now put the values which are given in the question. What is the value of small w? The value of small w over here is 4.15. It is 4.15 divided by the equivalent mass of the acid, we don't know. So write it as E only, multiplied by, what is the volume given over here? The volume it is given 500 ml. So convert that volume into liters. So it will become 0. How much? 0.5 in liters. So now this is the normality of the acidic solution, that is 4.15 divided by E into 0.5. Now we have to follow the normality equation. N1 V1 is equal to, now the normality equation, N1 V1 of the acid, N1 and V1, this number 1 is for the acid and N2 V2 is for the alkali, that is sodium hydroxide base. Now N1 we have already calculated over here in terms of E. So over here in place of N1 I will write 4.15 divided by E, capital E, into 0.5 into V1. What is the volume of the acid which is required to neutralize? It is 20 ml. So I will write over here 20. That will be equal to N2. N2 is how much? Look at the question carefully, read over there very carefully. N2, it is given N by 10. N by 10 is how much? 1 by 10. 1 by 10 multiplied by, what is the volume of sodium hydroxide? Again it is 20. So I put over here 20. So upon simplification over here in this equation over here, E is the only unknown thing which we have obtained over here. So that upon simplification, if we simplify this, we will get the value of E as 83. The equivalent mass of the acid is, it is 83 gram equivalents per mole. 83 gram equivalents per mole. Therefore, molar mass of the dibasic acid. Therefore, you can write down molar mass of the dibasic acid will be equal to, it is a dibasic acid, so we have to multiply E into 2. Whatever value you have got, this value of E multiplied by 2, dibasic acid. So that is why it comes to 83 into 2. You simplify it, you will get 166 grams per mole inverse. So this is the answer. Look at the question very carefully and look at the solution also. It is a very simple question. 4.15 gram of an acid are dissolved in water and the volume of solution is made 500 milliliter by adding water. 20 ml of this solution requires 20 ml of N by 10 sodium hydroxide solution for neutralization. If the acid is dibasic, calculate the molar mass of the acid. So let me go through this once more. Let the equivalent mass of the acid be capital E. Now normality of the acid solution, the formula, let the acid solution normality be N1. The formula which I have given you in the notes over there, assignment notes, W by E into V in liters. So that is coming to 4.15 divided by capital E into 0.5. It is 500 ml, convert this into liters, 0.5. So upon simplification we will get the value in terms of E only. Now by using the normality equation, N1 V1 of the acid is equal to N2 V2 of sodium hydroxide. Put the value of N1. This is what? This is our N1. Normality of the acid solution. So N1 is 4.15 divided by E into 0.5 into 20. Volume 1 of the acid is 20 ml. That is equal to N2 of sodium hydroxide. N2 of sodium hydroxide is N by 10, that is 1 by 10. So 1 by 10 into volume of the sodium hydroxide is 20 ml, so multiplied by 20. So upon simplification, this comes to E is equal to 83 approximately, exactly I think. Now since the acid is a dibasic acid, they are told over here, the acid is a dibasic acid. That is why if you multiply to this equivalent mass, the equivalent mass of the acid by 2, dibasic means 2. So E into 2, so 83 into 2 will give us 166 grams per mole, which is the equivalent mass of the acid. So this is how we are going to solve this sum. Please go through this sum again and again and remember the formulas which is given over here and the definitions as well. Now we shall go to the next sum. Okay, dear students, now there are 4 more sums left to be done from this chapter, which I will do in the next part, that is part 3, and try to complete this chapter before your midterm half-yearly examinations. Thank you so much.